Morning. I'm Jessie Pies from Rohini College. So I'd like to explain about uniform bending. So uniform bending means here the beam is loaded uniformly on its both ends. The bending of beam forms an arc of a circle. So the elevation is produced in the beam. This type of bending is known as uniform bending. So here we apply load on both sides. So the beam bend in the form of an arc. So it is elevated. So considering the theory, we are taking a beam and it is kept over the knife edges. Here CD represents the knife edge, so that AC is equal to BD. So the beam is loaded with equal weights W at each ends, and the reaction on the knife edge are acting vertically upwards. So here the external bending moment is W into AF minus EF. That is equal to W into AC. So that's W into A. So the internal bending moment is Y into I by R, where Y is the Young's modulus of the beam, I is the geometrical moment of inertia of the beam, and R is the radius of curvature of the beam. So in equilibrium position, external bending moment is equal to internal bending moment. So the equating to W is equal to YI by R. Here Y is the elevation and L is the distance between the two knife edges, that is C and D. Then by the properties of circles we can note CD is equal to L and EF is equal to Y. You can see the diagram. From the properties of circles, EF into EG is equal to CE into ED. So EF into we can write as 2R minus EF is equal to CE square. So here we can substitute the values. EF is equal to Y and C is L by 2. So Y into 2R minus Y is equal to L by 2 the whole square. So we can take 2Y or minus Y square is equal to L by 2 the whole square. So that's equal to L square by 4. Since Y is small, it can be neglected. So 2YR is equal to L square by 4. So Y is equal to L square by 8R. So we can cross multiply and take 1 by R is equal to 8Y by L square. So we can take the value of 1 by R. So while substituting, we can get the value as Y is equal to WAL square by 8IY. So here we can rewrite W as M into G. So we are getting the value Y is equal to MGL square by 8 BD cube 12 by Y. Since the rod is in the form of a rectangle, we are replacing I by BD cube by 12, where B is the breadth of the beam and D is the thickness of the beam, from which the Young's modulus of beam is determined. Thank you.